we have a survey, and the people that were surveyed in this were asked the question, what is your favorite meal? And they were given three choices: breakfast, lunch, and dinner. And 347 people were surveyed. We have the percentages, which means that that's how many people, if 100 people had been asked, that's how many people would have given each response. We want to know exactly how many people said lunch, and how many people said dinner, and how many people said breakfast. So how do I figure out how many out of those 347 people said that lunch was their favorite?
33.7% divided by 100%, and then you multiply that by 347.
Okay, good. So 33.7% means 33.7 out of 100. So we can just write that as 33.7 divided by 100. It would be okay if you had percents on those also. But we want to know what 33.7% of 347 is. And of 347 means multiply by 347. So we punch into our calculator 33.7 divided by 100 times 347. And what does that give us, Emily?
117. And I just rounded to 117.
All right, so we get 116.939. And it doesn't say in this problem to round it, right? So does that mean we shouldn't round it? Or should we? We should. Why? This number represents the number of people that said they like lunch the best. So if we're talking about the number of people that like lunch the best, why does this number right here not make sense? Yeah, you can't have a decimal part of a person, right? You can't have 0.939 people. So we're going to have to round this to the nearest whole person, which is going to be what? 117. So by rounding to the whole person, we're rounding that ones place, which means we get rid of all the decimals, and that 9 tells us to raise the 6 up to a 7. So we get 117, and since we had some work in our box here along with an answer, we need to make sure we identify our answer with a box or a circle, so make sure that it's clear that that is your final answer. Same thing for dinner. We're going to do 8.4% of 347. So what do we type into our calculator? Good. So we're doing the same thing, just a different percentage. So 8.4 divided by 100 times 347. And that gives us another decimal. What's the decimal going to be, Alonzo? So we get 29.148, and just like the last one, this is the number of people that said dinner was their favorite meal, so it doesn't make sense to say 29.148 people like dinner the best. So what are we going to do with this? Round it. Now, this time when we round to the ones place, get rid of the decimal part. What's that 1 going to tell us to do to the 9? It stays as 29. What if it told me to go up? What if it was a number that was bigger than 5, and we had to raise that 9 up to a 10? Can we do that?
Yes.
We could, except it wouldn't be a 10. It wouldn't be 2010. It would be 30. Exactly. Last one, doing the same thing. 57.9% of 347 is going to look like what when we type it in the calculator? Okay, and what do we get? $932. Okay, just like the other two, we need to make sure that we have a whole number of people. So we're going to round to the ones place, get rid of the decimal, and when I do that, what's going to happen with this 0 in the ones place? It's going to go up to a 1, so it's going to become 201 people. All right, now a couple of things here. We need to wrap this up. One is make sure that these numbers make sense. And what can I do to make sure these numbers make sense in the context of this problem? Add them together and make sure that they add up to the total. All right, and if they don't, we'll try to figure out why they don't. But if we add these up here, 117 plus 29 plus 201, what do we get? We get 347? Cool. So that's a good check here. Since all of these votes add up to the total number of votes, 347, what should all of these percentages add up to? Should add up to 100. Let's check that. We'll add those together. 33.7 plus 8.4 plus 57.9 is 100%. I see a lot of people leave the percent off of their 100 here. Make sure you put that percent on there. Okay. It is possible for this to not add up to 100 for a few different reasons. It could be because of rounding. It could be because not all the votes are represented, or some people voted more than once. So you need to make sure you add these up to check to make sure it is 100, because sometimes it won't be. And if you put 100% in there and it's not supposed to be, then not only is that going to be wrong, but it's going to be misleading as far as what we get over here also. So at the bottom of the opener, I know there's not a whole lot of room down there to work this problem, but we have a word problem that is going to involve proportions. So let's just review as we go through this problem the steps that we're going to take to do this problem. What's the first thing we're going to do when we have a word problem like this so that we can set up our proportion? We're going to write a ratio of units to start with. All right, so I'm actually going to write this out. Ratio of units. So we remember what ROU stands for. And what are the two units that are being compared in this problem? Miles and gallons. So miles is measuring how far the car drives. Gallon is measuring how much gas is in the car. So those are the two units. We can just put them in the order that they are there. So we can put miles on top and gallons on the bottom. If you did it the other way, you would get the correct answer as long as you set everything up correctly. All right, so everything we're going to set up, our two ratios that we're going to write, are going to use this order. We're going to put miles on top and gallons on the bottom. All right, so find some space if you haven't done this already, and we need to write two ratios. One ratio is going to include two things that we know, and the other one is going to include something that we need to know. So what two numbers here, miles and gallons, do we know go together in this problem?
125 and 4.
125 and 4, right? So it says your car can travel 125 miles on 4 gallons. So those two numbers go together. And which one's going to go on top? 125. Why does 125 go on top?
Because the miles are on top.
Because miles go on top. We wrote our ratio of units with miles on top, so we make the 125 miles go on top and the 4 gallons go on the bottom. All right, in the other ratio, we have something that we know, but we also have something we need to figure out. What is the one that we know? What's the number that we know for the question? It says, how many miles can you go with 15 gallons? So what do we know? We have 15 gallons, right? Where's that 15 gallons going to go? Does that go on top or bottom? That goes on the bottom, and then the question's asking how many miles. Miles goes on top, and we don't know that, right? So what do I put there? Yeah, we need a variable. M would be good, or D might be a good one for distance. I wouldn't recommend using G here because G might represent gallons. So just some sort of variable representing the distance the car is traveling, and remember that answer is going to be in miles. Now, how do I solve this? Cross multiply. So we multiply 4 times m and get 4m. And we multiply 125 times 15 and get a big number, right? What is it? 1,875. And then we solve this equation. Remember, when you're solving any equation, you need to set it up first by circling the variable, draw the line of equality, and then what do we do to get m by itself? Divide by 4. So we get 468.75. First of all, what is the 468.75?
Miles.
That's miles, right? That's how far the car can go on that number, that many gallons of gas. But before we write that as our answer, we need to make sure that we follow the directions here. And the directions say round to the nearest tenth of a mile. So rounded to the tenths place, that's going to be which number here? The 7. So rounding that 7 there, we get rid of the 5, and that 5 is going to tell us to do what to the 7? We're going to raise it up to an 8, right? So what we end up with then is 468.8 miles. The next couple of problems we have here, these are percent change problems. It says that in the directions. We want to find the percent change for each of the following. Remember, percent change is the one where we abbreviate it with the percent symbol and then the Greek letter delta, which is just a triangle. And the percent change formula tells us to do what? Who can set this up for me? Good. So the percent change formula, if you don't remember it, is the new number minus the old number, and then divided by the old number, and then times 100% to change it into a percent. All right, so the 22 minus 15 tells us how much it increases or decreases. Then we divide by the original number to get a decimal based on the original amount, and then we multiply it by 100% to change it to a percent. After doing all of that, what do we end up with? We get 46.666 and a bunch of sixes. And that is a percent. Don't forget that is a percent. And so what do we need to do with our answer here? Niall? Round to the nearest tenth. So the tenths place is going to be the first one after the decimal. Get rid of everything after that. And when I get rid of the 6, what's it going to tell me to do with the 6 that I keep? Go up to a 7. So we end up with 46.7%. Now, there's one thing that I'm missing here for my answer. What does this 46.7% mean? Well, it means that it went up by 46.7%, right? It was an increase of 46.7%. So we need to show that it's an increase by putting what in front of it? A plus sign in front of it. You always need to have a plus or a minus when we're dealing with percent changes. All right, that way it indicates whether it's an increase or a decrease. If we set up the other one the same way, we get percent change equals new number is 22 minus the old number is 23 divided by the old number 23 times 100%. And that gives us another decimal. What do we get for that one? Okay, and should we leave our answer like that? No. Remember, it says round to the nearest tenth of a percent, so we're going to round that 3 and get rid of everything after it. And when I get rid of the 3, the 4 is going to, when I get rid of the 4, it's going to tell me to do what to the 3? Keep it the same. So we end up with negative 4.3%. Remember, percent change means that if we started with $100 with the first number, then how much would it go up or down if it went up by the same ratio or the same proportion? All right, what are we going to do first here? So we have a $12 t-shirt. It's 30% off. We want to know the final price. What do we start with? All right, so these are the ones where we're doing an increase or a decrease by a percentage. We always start at the full price, which is 100%, and then we make our adjustments from there. Since it's a 30% discount, what are we going to do, Alonzo? We're going to subtract that 30%, and that gives us 70%. All right, and then what that means is we're only really paying 70% of the cost of this t-shirt, but we don't want to work with it as a percent. It's a lot easier to work with as a decimal. So how do we change that to a decimal, Alonzo? Divide by 100 and we get 0.7. What do we call this number right here? That is a multiplier. So we call it a multiplier because we're going to do what with it? We're going to multiply it by something. We multiply it by $12. So we start with the $12. We multiply it by 0.7. And what does that give us, Alonzo? Okay. Is that our answer? 8.4? No. What do we need to do to fix that? Why do we need that? That is what? Okay. So what are we dealing with here? This is 8.4 what? It's not 8.4 t-shirts. It's 8.4 dollars, right? So when we're talking about money, we want dollars and cents. So we're going to put a 0 on there, and we also need a dollar sign. Now, we didn't have to round this, but sometimes with money, if we get too many decimal places, if we go past the second one, then we're going to have to round it to the nearest cent. All right, and I think that might happen on this one. We'll see here. So this one, we have to find two different multipliers. We need a multiplier for the 25% discount. I'll go through that real quickly here. 100%, add or subtract? Subtract 25% gives us 75%. That's the percentage that we're paying. And the multiplier then is going to be 0.75. And then same thing, but with the tax, we're going to start at 100%. Tax is going to make the price go up or down? Up. So we're going to add the tax. 8.2% gives us 108.2%, which as a decimal is 1.082. So to get the final price for this video game, after the 25% discount, but with the 8.2% tax, what are we going to do? And what does that give us?
40.575.
Okay. We have the problem that I just talked about, right? We have too many decimal places because when we're talking about dollars and cents, we just want how many decimal places? Two. We want it to be in the hundredths place. So we look at that 7 there. That's what we want to keep. Get rid of the 5. The 5 is going to tell me to do what to the 7? And if it's 5 or more, we bump it up, right? So this is going to be 40.57, or I'm sorry, 58, and really it's $40.58. So what else do I need on here?
Dollar sign.
Dollar sign.